Acha ji, for this session, what we'll do is that kindly, if you have any question, please raise hand before asking. Okay, so that I will stop appropriately and give an answer to you. Okay. So please do not open the mic without raising hand first and without my permission. So let me okay ji. So welcome to today's session, and today we are discussing the chapter number 14 of uh, business statistics and decision making approach by Grobner. So in this chapter, what we are focusing is to study the multiple regression analysis and how to make a model out of it. So we will be building our previous discussion on what was the regression analysis, and now we're going towards regression with more than one independent variable. So let's start. So this chapter, what should be what is the expected aims or goals we will achieve? You will be able to make a multiple regression model. You will be able to interpret it, that how more than one variable is handled. You will be able to understand that how it can be used in business decision making. You will be able to interpret the output from Excel or R, that we will do it separately. And then you will check the significance. You will check that if the model is significantly creating a difference or not. So what are the goals? You will be able to make a non-linear model. You will be able to recognize and compare different competing models, which one is better, which one is not. You will be able to incorporate dummy variables, which are in this chapter. Okay, so bear with me. So we will try to complete it in 1 or 2 sessions. So let's move on. So in the previous discussion, what we did is that their regression line can be written in 2 ways. First is the population model, where the intercept and slopes are written in Latin words. So you can note that these are Latin notations: beta 0, beta 1, beta 2, beta k, epsilon. And in the sample regression, which is estimated model, it is English letters B0, B1, B2. And the other difference that you can note is that there is no error term here. Why? Because we already know in the previous class that in a sample, the average value is 0. So the error term, we will write it as E. So in a sample, average of error term is 0. So we cannot report it here. So it's already 0. So we can write it as 0. And there's another difference, that there's a hat here. This means this is what? So Y is reality and Y bar is estimation of it. So how we estimate it. So this is estimation. So these are two ways to write a thing. So when we are making a theory, so we are actually writing a population model. But when we estimate, do is using a regression analysis, we go towards the estimated notations, or we can call it sample notations. Okay, so these are two differences. So multiple regression is that there will be one dependent variable and more than one independent variables. So these are some properties of multiple regression. So since there are more than one independent variable, the graph will be look like a three-dimensional if there are two variables. So you can look at it here is the y is the outcome which is in terms of y hat, and one independent variable on y x-axis, other is on z-axis. So you can estimate you can see it here is that the x1 has a positive slope and x2 also have a positive slope, and both jointly have a positive slope. So it means beta 1 is b1 is positive, b1 is greater than 0, b2 is greater than 0. Since both are positive, so their effect is added to form a higher place. So this way you can calculate the slope of the. So we usually don't draw two-dimensional graphs, three-dimensional graphs, but it is giving us an idea how it will look like. But we cannot make more than three-dimensional. So luckily, you will not be able to. You don't have to study that graph because you cannot draw more than three-dimensional. Okay, let's move forward. Similarly, it has given us a so it is now giving us a value of how we calculate an error term. So using the independent variables x1 and x2, we make a model and we estimate y hat. We already discussed how to calculate y hat. We do is we put the value. When we do a regression, we will have a value of b0, we'll have a value of b1, we will have a value of b2, and when we put the value of x1 and x2 from the data, it can be a present value, that value which we have, or it can be average value. It depends upon what we want to achieve. So if we give a present value, it will estimate the present value of y. If we give them past value, it will give you estimated past value of y. So that's why we can calculate y hat. So y hat is estimated reality, y is an actual reality. So we discussed in the previous class that there is an event, and event is somewhere here, but the regression is predicting it. The event is somewhere here, and regression is predicting this much. So how much will be the error? So y minus y hat is the error. Okay, and this way we can find the error. So this two-dimensional graph, it follows one rule, that regression tries to fit the equation y hat, and it tries to make sure that the square of all the error terms is minimum. So what it says is it will solve the problem. It will minimize summation of error term square. So this is the property, and while the minimizing, it will calculate what? B0, B1 and B2. So using that process, it will calculate us these values. So this is the process of statistics, where you have the values of y, x1 and x2, and you calculate B0, B1 and B2. So this one is discussed here. Okay, let's move forward. So what are the errors? So errors are actually the difference between reality and estimated reality. So you predicted that there will be some outcome today, and that event does not occur. So the difference will be the error in the prediction. So what are the properties? And these are universal properties that you have to remember. So error term should be normal. Error term should be normal. We already discussed that error term should have skewness is equal to 0, kurtosis is equal to 3. So we can also check it using the histogram, using box plot, or we have just discussed few other tests. What were those? So it was JB test, Shapiro-Francia test, and Shapiro-Wilk test. So there are 3 tests that are available in softwares that can be used to check the normality. Second is the mean value should be 0. So this property is always fulfilled because we did it like a way that it should be 0. It's by construction. So the method that we are using is So it will always be 0. Second, it should have a constant variance. So it means error term square of should be constant. What does it mean by that? It means if you let me write. So if you split the data into two groups, so let's say error term square of group 1, it should be equal to the second group. So it means if you split the data into two sub samples and you estimate the regression separately, ideally the error term square should be equal. This means the variance is constant. If they are not equal, then it will mean that there is heteroscedasticity. Okay. Secondly, last property is the error term should be independent. What does it mean by that? So it means that the present error term, that is ET, should not be let me write in another way. So the correlation between error term t and error term t minus 1, yani error term today and past error term should be equal to 0. So there should not be any correlation between past and present error term. So we will go discussing its logic in the coming slides, but these are 4 properties that are very important, and a few of them we already discussed how to test, and we will go towards software and we will study how to test it in the software later on. Okay, so let me clear it up. Yes, you can ask question.
अस्सलाम सर सर अगर हमारा हेट्रो का इशू आ रहा है, मतलब हेट्रोसेडासिटी एग्जिस्ट करती है, तो इसका क्या मतलब डैमेज होगा हमारे रिग्रेशन पे, या मतलब इसका इफेक्ट जो होगा?
इसका मतलब यही है कि अगर हेट्रोस्केडासिटी आ रही है, सो इट मींस दैट 2 सब सैंपल जो बनाए हैं, एक में वेरिएंस कम है और एक में ज्यादा है. ठीक है, अगर एक में कम है तो वो वाला पोर्शन ज्यादा एफिशिएंट है, जिसमें ज्यादा है वो एफिशिएंट कम है. तो इसका मतलब हम उनको आपस में कंपेयर नहीं कर सकते क्योंकि उनकी एफिशिएंसी एक जैसी नहीं है. तो अगर हम एफिशिएंसी एक जैसी नहीं, तो हमें उनको अलग-अलग रन करना चाहिए. लेकिन अगर आपकी हेट्रोस्केडासिटी ऐसी है कि हर ऑब्जर्वेशन पे वेरिएंस बदल रही है, तो अब सब सैंपल कैसे बनाएंगे? हर ऑब्जर्वेशन डिफरेंट है. ठीक है, सो इट आल्सो मींस कि जिस प्रोसेस के जरिए वाई कैलकुलेट हो रहा है वो प्रोसेस सिस्टमैटिक होना चाहिए, वो फॉर्मलाइज्ड होना चाहिए, ताकि हर साल जो वाई कैलकुलेट हो रहा है वो एक सिस्टमैटिकली कैलकुलेट हो रहा है, उसमें वेरिएंस कांस्टेंट आ जाएगी. हाँ, यानी और कोई क्वेश्चन है इसके अलावा? हाँ जी, कमल.
नो सर, क्लियर है.
ओके, हम हेट्रो का चैप्टर पढ़ेंगे आगे, तो मैं हमने हर प्रॉब्लम पे सेपरेटली चैप्टर पढ़ना है ये इस मॉडलिंग के बाद. तो हम उस पे डिटेल डिस्कशन करेंगे डिसिप्लिन वाइज, रिसर्च वाइज, कि ये प्रॉब्लम है क्या और कैसे सॉल्व होगी. तो जो आपका क्वेश्चन है उसका डिटेल आंसर उस चैप्टर में मिलेगा आपको. ठीक है, चलें आगे चलते हैं. Let me clear it. Go to next slide. So before we start any model, so what we have to do is we have to specify it. So specification include, we have to find what should be our dependent variable. Okay, it may come from your title or research question or research problem. So when you're writing a term paper or a thesis, it will help you to define your dependent variable. Okay, further you have to find your potential independent variables. It will come from your literature review or research question, both are calculated from each other. So research question is actually made from literature review, and literature review is actually did to achieve a research question. Then you have to do is, for these dependent and independent variable, you have to calculate a collector data. Ideally, it should be at least 30 observations that we discussed earlier, that 30 observation will help you to assume data to be normal. Otherwise, you have to make it normal. And we already know that none of the variables can be normal in reality because of the nature of the data. Okay, so let's. So after that, when you collect the data, you have to calculate the correlation between independent and dependent variables. And what it will do is, it will help you to find find if there is any association in the data. Otherwise, data will be data, or the data is having coincidence. So in order to estimate a regression, first of all, we have to rule out if there is a coincidence. Okay, so how we can do it? So first of all, we have to see if there is any association. So if there is an association and it is significance, we'll do it in a test and then we'll discuss. Then we can say that there might be no coincidence, it is because of a theory. So we can go towards regression. So this way we can go towards building a model. So let's move forward. So for example, he is giving, there's a distributor of frozen desert pies. Somebody is distributing desert pies, and he wants to evaluate the factors that are influencing the demand. So to estimate demand, we use the variable that is sales per week. So why we take sales as a frequent proxy of demand? So in economics, we already know that in equilibrium, demand is equal to supply. Okay, so demand is equal to supply. So we take the sales as a proxy for demand. Then the independent variable that he has selected is price and advertising expenses. So price, we already know it will work as a direct variable, and advertising is the demand motivating factor. So there are two variables. So he has collected data for 15 weeks. Okay, so data is per week. So it means n is equal to 15. So data has 15 observations. Move the slide. Okay. So the data is shown here. So it's a 15 observations, and the sales of the data, and the price of the data, and advertising expense. So he has this equation to estimate, and since it is estimating, so he used was sales hat B0, B1, and B2. So assuming that it will follow the properties, that's why error term is 0 here. So he will calculate he has calculated the correlation matrix. So we already seen that price and sales are correlated minus 0.44, and advertising and sales are related by 0.55. So what does it mean? That it shows that the changes in price and sales are negatively similar, or inversely proportional to each other by 44%. So it means that if the price is increasing, then the sales are decreasing. So their inverse movement is 44% similar. Means if price is increased by 1 unit, the sales is coincidentally or luckily decreased by 0.44 units. Similarly, if advertisements increase, then sales increase by and their movement in same direction is shown by the positive value of correlation. So it is 55% similar. Okay, so this way you can calculate the correlation and interpret the correlation between variables. So you can note that the correlation values are relatively high. So it means these variables are useful in estimating the demand of the pies. Okay, so move out. So now we have to estimate the regression. So he has estimated the model in the background, and he has found out the slope B1 and the value of B1. So it estimates that. So what is B1? So it estimates that the average value of Y change Y. So it tells us, let me change the color. So it will tell us the average value of Y changes by B1 units for each unit increase in X1, holding other variables constant. So it tells us, first of all, that for 1 unit increase in X, okay, holding other variables constant, which is X2, okay, how much Y will change? So that is B1. So if I write that change in X1 is proportional to change in Y. So if X changes by 1, Y change by B1. Okay, so if X2 is proportional to Y, so if X2 changes by 1, then Y2 change by B2. So it's a proportional thing. So for example, if B1 is minus 20, then sales is expected to decrease by 20 pies per week. So this is the units for each dollar increase in selling price. So it means that if the seller increase the price by $1, he would expect that his sales will drop by 20 pies per week. The net effect of the change is due to advertising. So this effect of 1:20 is because of a certain value of X2, which is constant. We don't know, but we assume that if that value changes, then this proportion might also change. That's why it is saying that due to changes due to. Okay, so that's why it is saying they're holding other constant, because if others are changing, then this value might change. So 1:B1 is equal to 1:20, 1:-20, because it is shown here. Similarly, what is B0? It is the average value of Y when all independent variables are 0. So what we can call it? It is let me write it here. It is the stable value of Y when independent variables IVs are 0. So it means when you are not forcing on changing the model, means your independent variables are 0, then what will happen to Y? So that the Y can be anything. So it can be 0, it can have some value. So intercept value gives us that thing. So intercept is the effect of variables which are not in the model. So because they might have some effect that is shown in the intercept value. Okay. So it has shown again the correlation value. So the correlation between pi sales and price is minus 0.44. So it is telling us that it is negative association. And the correlation value is between -1 to 1. And in middle it is 0. So here it is 0 minus 0.5. Here it is 0.5. So any value in this region above 0.5 or below minus 0.5, we call it strong. And if it is in between 0.5 and minus 0.5, we call it weak. WEAK. So sales between advertising and sales is 0.55. So it is positive association. So I have shown you two things. First of all, the number above 0.5 is strong, below 0.5 is strong, and in between it is weak. And the number between 0 and 1 is positive, and between -1 and 0 is negative. So these are the interpretations of correlation value. Okay. So he's what he are doing is trying to see the value in the graph. Let me load the graph. So it has shown us this value. So it looks like, let me estimate. So here we can see that what is the pattern shown in these dots. So it looks like this. That's why the dots are going downward. So it means the sales and the price are negatively associated. Here you can see it that the dots are forming like this. Okay, let me make it more relevant, crossing from the middle. So numbers are more positively. So sales and advertising are positively associated. So the values that we seen on the correlation is actually calculated from this side. So this is negative, this is positive. Okay, and this confirms the negative value. And how we estimate the number shown in correlation represents the spread of dots around the line. So more nearer the dots are, more bigger the value is. So it's positively, so that it was 0.55. 0.55. So it was bigger. It was minus 0.44. So they are more spread away from the line. That's why number is not bigger towards 1 or -1. So this, from the graph you can estimate the correlations. Let's move forward. He is giving us, so you can use many softwares to find the coefficients. We already discussed the regression in Excel. This book is about PHStat, well, but we will be focusing on RStudio. Okay, so let me move forward. So this software has done estimation in Excel. So the answers are sales equal to 306.526 minus 24.975 price plus 71.131 advertising. And we will come back to the other things, but this is the, so this is the value of B0, this is the value of B1, and this is the value of B2. And if you put the value of X1 here and X2 here, you can calculate Y hat. This way, first of all, you put the values and then you solve it to get the estimate. Okay. So he has given the interpretation. So you have to look at it properly so that we don't have to come back here again. So the sales is number of pies sold per week, and price is in dollars, and advertising is in $100. So beta 1 is minus 24.95. So it means that sales will decrease on average by 24.975 pies per week for each $1 increase in sale price. So it means if a seller increase the price by $1, the price increased by $1, the sales will fall by 24.975 units, which is pies per week. So it means that there is an inverse or negative relation between price and sales. Then we can see it here is that sales will increase on average by 74.13 pies per week for each $100 increase in advertising. The net effect changes depend on the price, and the net effect changes. So it is telling same thing. So what does it mean? So it is saying that if you change both of the variables together, the outcome may be unknown. It depends upon how much you change. So when you're saying that increase in price by $1, you first have to assume that the advertising is not changing, so that you can have a clear value. That's why it is assuming. Similarly, if you change the advertising, you have to assume that price is not changing. That's why there is this value. In real life, definitely both of them are changing together, so it's more complicated. But in our next sessions, we will be learning how to handle that issue, that in real life variables change together. Okay, so anyone who have a question here, please raise hand, then I will move forward. Otherwise, if you don't have any question, I will move forward. Anyone? Please raise hand. I will open the mic. Okay जी. हाँ जी.
सर हमारे जो पिछली कोरिलेशन का हम जब टेस्ट करते थे तो 0.9 आ जाता था, तो वो कहते थे कि 0.9 अच्छा नहीं है रिजल्ट, और आपको वो वेरिएबल रिमूव करना पड़ेगा या चेंज करना पड़ेगा.
ओके, मैं वजह बता देता हूँ ना. आपका जो वो डेटा था वो टाइम सीरीज था. टाइम सीरीज में कोरिलेशन उतनी बड़ी आनी चाहिए. ठीक है,
आनी चाहिए.
हाँ, मतलब उससे बड़ी हो तो अच्छी होती है. ये क्रॉस सेक्शनल डेटा है, क्योंकि डिफरेंट पाइज को चेक किया है, यानी मेरे वी आर अज्यूमिंग दैट इट इज क्रॉस सेक्शन डेटा, तो उसमें इतनी भी बहुत होती है. ठीक है,
ओके सर.
जब हम क्रॉस सेक्शन टाइम सीरीज को डिटेल से पढ़ेंगे ना, वहां आप जाके इसका जवाब और क्लियरली आ जाएगा. ठीक है,
ओके सर.
और किसी को क्वेश्चन है यहाँ पे? एनीवन एल्स? नहीं है? चलें, लेट्स मूव फॉरवर्ड. Save it, hit the screen, go to the next slide. So what it is showing us. So what he is doing is he is trying to predict the model. So how it is predicting, he has said that let's assume that our tomorrow sale price is this. I'm trying to sell at this, and I'm advertising expenditures are this. So what will happen? So I will put 3.5 because it is in hundreds. So 350 divided by 100 is equal to 3.5. So I have to convert it in relevant units. And then price is 5.5. So I will put it in. So I know that if my prices are 5.5 and my advertising expenditures are $350, then my expected sales are 482.428.62 pies in that week. So if the values of price for that week is this and the advertising expenditure is this, my estimated value of sales is this. So that it means if my model is true, what should I do? I should plan to prepare these many apples, these many pies, and manage sales. So you have to make sure you have a space to show these pies, and your production line has a capacity to produce these many pies. If you don't have, then you have to develop capacity to produce these many pies. So because this is your expected sales. So people are expected to buy these many apples on average. Okay. Let me see what comes in next slide. So same thing is done in pH stat. So in regression, so in a regression you can run the multiple regression, and you can also get the confidence intervals. We'll come back to this topic on confidence interval later on. Okay, so what it is doing is you give the value for y, and so it has estimated y hat. So here you have to give them the values of x. Anyone who have a question here, please let me know. Okay, so these are slides related to the confidence interval. So we have not studied that topic in detail. We'll go towards that when we have the detailed knowledge regarding regression. So I am going to skip few slides here. So I will let you know which slides are being skipped. So first of all, now, but we are discussing few of them in between. So the next point that we're discussing is the coefficient of determination. So we have discussed it when we were discussing the simple regression. We found out that the R square is actually total knowledge or total change in dV, means dependent variable, and total change accounting to IVs. So R square is how much y has changed and how much it is explained by changes in because of our independent variable. So in simple words, I have written in the previous slides was that the known knowledge and total knowledge. Knowledge of what? Knowledge of why dependent variable is changing. So there are millions of theories that could explain why a dependent variable is changing depending upon the scope of the variable. And because of our literature and research, we come up with several logics and several variables that could explain the changes. So it means the independent variables will explain the known knowledge portion of the total knowledge, and that is R square. So it has discussed R square here. So R square is sum square regression. So this is total information because of the independent variables, and this is total information that was to be explored, and this is the information that is successfully explored. So successful explored information and total information, when you divide it, it is 0.52, and it is already shown here. So in an Excel research output, so what does it mean? It means that the 52.1% of the variation in the Apple sales, that is knowledge, that is information that we have. Okay, and we are able to gauge that the 52.1% is because of price and advertising. Okay, so this was the interpretation of R square. So what is adjusted R? So there's another topic that you can see in that output. There's another adjusted R scale. So we'll discuss what is that. So adjusted R is an advanced form of R square. So let me give you some background. So we have already discussed in the previous class that let me write it here so that it gives you clarity. So when we increase our IVs, which is independent variables, there is more information that we can explain, or more the information that we know. So it means it will increase R square. But the more variables we add, the more complicated model will become. So it means there's a trade-off between simplicity and efficiency. So what does it mean by simplicity? Let me write now. So simplicity means that how easily we can explain. Simplicity means how easy to explain the patterns in the dependent variable. And what is efficiency? How much accurately we can explain. So if you need more accuracy, you need more variables. If you need to be simple, you can reduce variables. But the problem is, if you are simple, most probably your R square will be low. And if you are complicated, you are precise, but your R square may be and your R square may be very high. But the problem is, it may be difficult. It will be complicated. So it is saying that R square will never decrease when you add a new variable. So increasing variables will increase your R square, but it can be disadvantage when comparing with other models. Why? Because variables are complicated. It will make your model difficult. So what is the net effect of adding new variables? So it is talking about. So whenever we add a new variable, we lose some of the degree of freedom. Degree of freedom is the information that is left, which is free to be used. So suppose you have 10 observations, you have one IV. So one IV. So it means you have 9 independent observations left. So we will do a mathematical numerical later on to explain what does it mean. So the more variables you will use, more degree of freedom will be lost. So the sample size minus the independent variables is your degree of freedom. So the formula for DF is degree of freedom is n minus k. So k is the number of variables that you use and n is total sample size. So logically, you cannot make it negative. So if you have 10 observations, you can have 10 variables, but you cannot go beyond. Okay, so adjusted R, what does it do? So R square will always increase. Let me clear it up and then write it here. So X increase, R square increase. But even if the X is useless, R square will always increase. But if X is useless, so increase in X will decrease adjusted R square. So what does it do is so adjusted R is actually, let me write it somewhere else. So adjusted R is R bar square is equal to R square minus the penalty factor for useless variable. So if your useless variable is very useless, so it will reduce R square. Okay, so adjusted R square. So when you are adding a variable, you have to look at the fact that if adding a new variable is reducing adjusted R, it means you should not add that variable. So it will give you a trade-off that let me give an empty screen and then we discuss here. So let's draw. So suppose you have this graph and here you have a value of R square, adjusted R square, and here you have a value of number of IVs. So initially when you increase the variables, the adjusted R will increase, but after a certain time, the model will become complicated. The adjusted R will tend to slow down. So it means this, you have a group of variables that you are trying in your model. So when you increase your independent variables, you will notice after a certain point, maybe variable number 4, 5, 6, you will note that adjusted R is not increasing anymore and it is decreasing. So adjusted R will help you to decide how many variables for that set of variables are useful. So let me write it here. So assuming that you have found the best set of variables, the adjusted R square will tell you regarding the appropriate set of variables to be kept in the model. What will happen with that? It will make sure that your simplicity and your efficiency are balanced. So this is the advantage of selecting the adjusted R. It will tell you when to stop, depending upon the quality of the variables. If the new variables are more useful, then it will tell you to carry on. No issue with the variable addition. Okay, so this is the concept of adjusted R square. So it is mostly used when you have abundant independent variables and you have to decide how many to keep. So mostly in your denomination, it depends upon, if you are working on time series data, you mostly might not have many independent variables. So adjusted R does not matter. But for cross-section research, usually there are abundant independent variables coming from a questionnaire. So then they have to decide how many to keep. So this way we select a set of variables. So the formula for adjusted R is, so I gave you a brief formula. So this is an advanced detailed formula. It is R adjusted is 1 minus R square, n minus 1, n minus k minus 1. So what does this say is that if you increase independent variable, that is k, so it is written as number of independent variables. So if you increase k, this number will become small. And if since it is multiplied by this, okay, so this become small too. So this will become large, because if this is small, then R square will become large. So it will solve. So eventually, when you minus with large number with small, so overall adjusted R will fall. So what does it say is that this portion is the penalizing factor. So this diagram shows the proportion of variation explained by y, that is R square, and x adjusted for the number of variables. So suppose adjusted R, let's see if the example is here. So more the variables which are unimportant, smaller will be the adjusted R square. So adjusted R will be smaller than R square. And the other advantage is, suppose one of you have estimated y is equal to alpha plus x1 b0 plus b1 x1 plus b0 x2 b2 x2, and other one has estimated b0 plus b1 z1 plus b2 z2. So both have selected different independent variables. So which model is better? So what we'll do is we'll see which model has bigger adjusted R square. So what it will tell is that considering the usefulness of the variables and the number of variables, which model is explaining better. So adjusted R square is high. It will tell us the usefulness of selected variables. Okay, so this way we make our model, and this is the way we explain adjusted R. Okay, so let's move forward. Then it has explained adjusted R. This is 44.172. So it is variation in the pie sales explained by the variation in the price and advertising, taking into account the sample size and number of independent variables. So it is saying that assuming the sample size is 15 and there are two independent variables, which is price and sales, how much will be the R square? That is 44. So if you find any other good variable and you replace with adjusted advertising, and if that adjusted R increases, it means that is a better variable. Or if you add a third variable, if you add a third variable, suppose if I add one more variable, so third variable, and it leads to increase in adjusted R, it means that variable will be useful. So it will justify the addition of that new variable. It will justify the reason for making model complicated. So let me conclude it here so that we can properly understand. So if by adding another variable there is increase in adjusted R square, then it means that we can afford to complicate our model, because the gain from new variable is more than the cost of complication from that new variable. So let me include it with one more statement, that is adjusted R square increase means the benefit is greater than cost for that new variable which is just added. So this is the logic for using adjusted R in the model. Okay, so let's see what's coming up. So next is the question that first of all we have to answer in every regression, that is our model significant? Means does our independent variable jointly explain the significant portion of changes in the dependent variable? Does they actually explain the changes in the dependent variable? So F test of the overall significance, F test is used for overall significance. So this is the test where we call it. So why we call it F test, I will tell you in coming slides. This test shows that if the linear relationship between all of the x variables considered together and y, so it is saying that this test will confirm that if all the independent variables are linearly affecting y. Okay, so let me include it here. This F test tells if all the selected IVs are linearly explaining or linearly related to y, which is your dependent variable. So we use the F statistic. The hypothesis for that is, null hypothesis is B1, B2 and Bk all are equal to 0. Means none of the independent variable is useful. All are equal to 0 means not any one IV is useful. Not even anyone. So this means all the variables are junk. So, and it is alternative hypothesis, at least one is useful. one is useful. At least one of them is performing and explaining the patterns in Y. So if any one is useful, you will notice that F value will show that model is significant. Let's see how we test it. So the formula for F test is, let us go back to what we meant by SSR. So what was SSR? It was total known information. And what was SSE? Total unknown information. So regress and let's see what is MSR. So MSR is average known information. What is average? It is average per variable. So SSR divided by K. So average known information per variable. So I should have written average per variable known information. Okay. And what is MSE? So n minus k minus 1. So average unknown information per degree of freedom. So this is n minus k minus 1. So degrees of freedom it's written as. So average unknown information. So why we divide by k here? So because we generated information because of variables, so its k is here. And we could have generated more information because our k can be equal to n. So we could have added more variables. So we left the model simpler by not adding variables equal to n. So we have left some data free. So degrees of freedom. So that's why it is here. So error is related to free observations and information is related to used tools, which is independent variables. So what is F test? F test is comparing average known information divided by average unknown information. So if this number is high, what it will mean? It will mean that we have more known than unknown. So we want to make a model where on average we have more known information than the unknown information. Because if the unknown information is more than the known information, then most probably the result might cancel out. So your known information might be opposite to the unknown information and they are cancelled out and there is no change. So for a model to be a good, we need to make sure our F value is big. And how big it should be, we'll look at it in the next slide. So question is that how big the F value should be. You will cover it in next slides. So in the regression, what is done is it is 14730.13 divided by 2. Okay, 29460 divided by 2 is MSR and 27033 divided by 12 is this. So we divided and the answer is this number. What does this number mean? This number means that our average known information is 6.5 times more than unknown average information. I think it is clear now. So what does F gives us? It compares with the average known information with average unknown information. So we need to first of all calculate how big the known information is. So the F test is telling us that known information is 6.5 times more than unknown information on average. Now we need to find out if it is big or not. For that, there are several ways to be used, but in our Excel, in our softwares, they give us the significance value. So we can use this number to check if this number is big or not. So let's see if it is telling us in the next slide. Okay, so what it is telling us here. So the null hypothesis is both independent variables are not useful. An alternative is both independent variables, at least one is not zero. Okay, so it has calculated the F value, which is shown from the previous slide, and there is a P value shown in the previous slide. So the critical value in the books is, so first of all, let's write about the critical value. The critical values are the thresholds developed by the statisticians to judge if the specific test value is significantly big or not. So this test value depends on the sample size and variables. So in each statistics book, there's a table shown at the end of the book. Okay, so since we so let me interpret it. So if the calculated value, so F calculated value is above F table value or critical value at 0.05, it means that we accept alternative hypothesis. So we accept the alternative hypothesis. This way you can say that since it is above the critical value, we can safely say that F is big enough to claim that the average known knowledge is more than average unknown knowledge. Okay, so anyone who have a question here, please raise hand. So we have already studied that if the model is fit or not. So that F test will help you to select, confirm that model is fit. Now we want to see if our individual variables are significant. So we have confirmed that all the variables together are significant, but now we need to confirm out of our independent variable which one of them are good. So we need to rank our, for that we use t-test. Okay, so t-test is used for our individual variables and f-test is used for all the variables together. So it shows if there is a linear relationship between x1 or x2 with y. So null hypothesis is there is no linear relationship, and alternative is that there is a linear relationship. Okay, so this test is used to compare individual variables. The formula for that is t is equal to beta 1 b1 minus 0 divided by standard error of beta 1. So y0 is here, so you need to remember that. So since we are comparing it with no effect, so since h naught has the portion that bi is equal to 0, so that 0, let me change the color, so that 0 is placed here. So it's a reference point because this is shown here. So if your null hypothesis is beta I equal to 1 and beta I not equal to 1, then the 1 will be shown here. So that 0 is because of this null. So if you put any number here, it will be shown here. So you already know Bi is slope and SBI is standard error of Bi. So this is the formula for the individual variable t-test, and what it will do is it will compare the slope which is different from the benchmark and the variation in the slope. So we want that our the excess slope which is slope minus 0 should be more than its variation. So more the variation is, the more unreliable the slope is. So we need to make sure our t value is big. Okay, so let's move forward. So in this regression table that you have generated from Excel, there is a t value shown here. So there is a t value for intercept, there is a t value for price, there is a t value for advertising. So here the t value for price is minus 2.316. So what does it mean? That the excess CESS slope is 2.3 times of its variation and in negative direction. So it's negative, so it's negative direction means that the slope is less than 0 because 0 was the benchmark. So but it is less than 0, but it is more than 2.3 times. Okay, so and the t value of advertising is 2.8. So the excess slope of advertising is 2.8 times more than its variation, which is standard error, and in the positive direction because it is positive. So this is the interpretation of t value. Now we want the t value should be big. So the question is how big we need. So we'll discuss that in the coming slide. So a good variable or a significant variable will have high t values. So first of all, we learned what does t value mean. Now we'll go towards how to find if the t value is big enough or not. So there should be a threshold value just like f test. So let's go towards that f value. So here you can see that in the table the t stat and the p values are given. So the null hypothesis is that the particular variable is useless or the particular variable is not useless. So for our model, we already know the values of the t. So in order to find the significance, we need the critical value as a benchmark. And we already know if the b calculated value is more than the table value, then we accept alternative hypothesis. What does it mean? Alternative hypothesis is that the variable is significantly affecting the dependent variable. So the slope is not 0. So that's why we use the t value, the critical value. So critical value is shown here as 2.17. So the fastest way to test is we check the p value. So if the p value is less than 0.05, we accept Alternate hypothesis, if the p-value is greater than 0.05, we accept null hypothesis. Same goes with the f-test. So f-test also have the p-value that you can check. So here both are less than 0.05. So you can put a star here in your projects, that you can put a star here and write it in the bottom that it is significant at 5% criteria because they are smaller than 5%. So the conclusion is both of the variables are significantly affecting the sales of, what you call it, the pie, sales of a pie. So let's go to next point. So this way you can confirm the slope of the variable. So there are two methods that are already discussed. First is the t-value method. Second is the p-value method. Now we'll go towards the third way. The third way is you can check the upper and lower interval of the variable. So if this is the lower interval and the upper interval, if so we can call it is there a notation? So lower value and upper value, if 0 is not in between them, then data is that variable is significant. So it is minus 14 and minus 1.3. So 0 is not between them. So it is significant. So 17 and 130, 0 is not between them. So it is significant. 57 and 555. So 0 is not between them, significant. So we have studied the third method. So if you have the t-value, you can calculate using the critical value or table value. You have to get the t-value, a table value. If you have the p-value, you can compare it with 0.05. But if you have the lower and upper limit, you can see if the 0 is in between. If it is not, then it is significant. So the interpretation of upper and lower limit is, let's see. So it is interpreting the upper and lower limit of price. Okay. So weekly sales are estimated to be reduced between this for each 1 unit increase. So we already know that if price increase by $1, the sales will decrease by how much? Minus 24 units. So but it is saying that since we are guessing it, so there is an upper limit and lower limit to this decrease. So it is saying that it could decrease as low as 1.37 and as high as 48.58. So it is telling us that for 100 cases, for example, this price is increased $1 100 times by 100 different sellers, the demand will decrease by the demand will decrease in between minus 1.37 and 48.58 95% of time. So it means in other words, it means that so in out of 100 cases, 95 times you will see that the demand is decreased between this range and its average value is 24. So 24 is actually what? It's a point estimate, and this range is interval estimate. Okay, so for every policy you will have a range and a center value. So center value will come from the slope value, and the interval estimate or the range will come from lower and upper limit. So you have to remember this. So since it's a guess, so you cannot say for sure that the answer will be equal to the slope. You can just say that answer is in between, answer is at the point interval, but you can guess that it will be between these two items. So in between 1.37 and 4.58. Okay, so let me Move to the next slide, then we'll discuss. Next is that it is talking about another point that is measured by regression, that is standard deviation of the regression. So, but it is telling us that there is a regression line. This is a point estimate of the relationship, but it has a lower boundary and an upper boundary. So that distance between the lower and upper boundary is standard deviation of the model. So the estimate of standard deviation of the model is SE, standard error of the model. It is calculated by this formula. SSE, what was SSE? We already discussed. SSE is total unknown information. And MSE is average unknown information. So square root of MSE is the error that the model is getting. So it is also written as RMSE. Root for under root, MSE means square error. So if you see RMSE or SE, it is same thing. Okay, so this is used to compare two models. So if you have two models, one has both have just used same variable. Suppose there are two theses. One have used ROA with intellectual capital, another has used ROA with corporate structure. So we want to see which model is better. There are two ways now. First is adjusted R square. Second is RMSE. So EView, Stata, and EView, Stata, and SPSS will show you RMSE, but theoretically it is known as SE. So the smaller, the better. The more small that RMSE is, the better the model is, and bigger the adjusted R, the better. So if the two models which have bigger adjusted R, the model is better. So this is another indicator that is being used in the interpretation. So let's see what are its different values. So in our Excel output, our standard error SE is 48.46. This is the standard deviation of the regression model. So this is placed here. So let's see. So this tells us how often the errors occur. So the bigger number is, more errors might occur in our prediction. So this is actually these are calculated from the prediction errors. So so the bigger the number, you will expect more errors in the model. So if you want to make sure that there are less errors, you have to make a model which has smaller standard deviation. Okay. So let's see so here is it try to interpret. So the standard deviation of regression model is 47.46. So it means that so the rough prediction range for the pie of sales is given per week is 94.2. So the rough prediction range for pie sales is given week is 94.72. It means the number will have this big range. So it is given an example here. The pie sales in a sample were 300 to 500 per week range. So this range is probably too large to be acceptable. The analyst may want to look for additional variables to explain more. Variation explains. So what it is saying is that if you have this number, which is 2 into SE, which we'll call it prediction range, PR, and you already have a range of a data which is 200, so R. So this range should be very small as compared to this number. So this range is 200 and this error is 94. So it is almost half. So logically, or sometimes people say it should be 10%. So this range should be 10% of this range, because what it is talking is that your data is changing by 200 points and your prediction has an error of 94 points. So it is almost half of the work. So this number should be 10% of this 200. So ideally it should be how much? 40, which is it is 20, which is 10%. So this way we will accept the quality of the model. So you have to check for your estimates if they are 20%, 10% of your prediction. Then after calculating the model, you have to make sure that this problem does not exist, because we are discussing it right now, because this error only comes when there are 2 or more IVs in the model. So we have already discussed that more variables means more efficiency, but the problem is more variables also lead to more problems. So multicollinearity is the high correlation that exists between two independent variables. So the regression model assumes that there should be no high correlation between IVs. So if it is high, then there's a problem. So this means two individuals contribute redundant information in the regression. So if they are highly correlated, it means they are showing same information. So there is an overlap, and that overlap will create a problem. So we'll discuss this in the coming slide. So including two highly correlated independent variables can adversely affect the regression results. Why? Because they are giving same information, and they will lead to large errors and low t-values. So it will make variables insignificant. Even though you think the variables are good, since since x1 and x2 are correlated, which is not equal to 0, it means there's an overlap which is creating instability, and it will lead to high standard errors. And you already know that t is equal to beta 1 minus 0 divided by standard error. So if there is high standard error, then it means there is low t value. So low t value means insignificant outcomes. So first of all, this problem. So you will do an effort finding good variables, and you think that the variables are good, but the problem that you might ignore is that they have high correlation. Because of that, the variables will have high error and low t values. It makes model insignificant. So at the end of the day, you will say that why it is happening to you. So further on, it may also do one more thing. Even though your model is good, but your expected signs are wrong. You were assuming that my beta 1 should be positive, but because of this multicollinearity, it is opposite. So there is no theory available, and you try to justify the what you call it wrong coefficient, which is not realistic in literature, and you end up getting lower marks in your projects because you're trying to estimate something that does not exist. This is because of high correlation causing multicollinearity. So in this few slides coming up, we are talking about how to solve this problem of how to detect this problem. Then in our coming chapters, we will talk about how to solve it. So what will happen if there is high multicollinearity? What will happen? You already know there will be incorrect signs. there will be large. So if you add new variable, the model will change drastically because there are high errors. So significant variable become insignificant because the overlapping will increase the standard error. Okay, the estimation of standard deviation of the model increases. So what will happen because of high multicollinearity? There is a high standard deviation. So high standard deviation means there is high interval estimate. So if there is high interval estimate, there is a high chance that 0 will lie between them. So we want to make sure that the confidence interval are not that wide, so that there is no 0 in between them, so that the model is significant. So this is a problem that will come when you are focusing on adding more variables other than one variable. So how to detect? The formula that is given by Gujarati econometrics, and the formula is VIF. It is called variance inflationary factor. So what does it mean by this word? It means how much variance will increase because of the correlation between the two variables. Okay, so what it is telling us? So here Ri square is correlation between x1 and x2. So VIF for these two variables is 1 over Ri square. So if the correlation is 0.9, let's call it 0.9. So answer will be 1 over 1 minus 0.9, that will be 1 over 0.1 equal to 10. So if the correlation is 90%, then the VIF is 10. So it is saying that if VIF is bigger than 0.5, then it means there is a problem. There is high correlation. So it will create a multicollinearity. So you have to select those variables which have low VIF values in between. So if you have three variables, you have how many VIF? One is x1 and x2, x1 and x3, x2 and x3. You have to calculate 3 VIF values. From that, none of them should be more than 5, so that you can safely say that there is no multicollinearity in the model. Okay.